Okay, so this is test 5 review. There are 33 questions. The first question is use the graph of the parabola to fill in the table. So the graph is given, we need to fill out this information. Does the parabola open upward or downward? You can see that it's facing down, so downward. Find the equation of axis of symmetry. Always to find the equation of axis of symmetry, you need to find the vertex. This point is the vertex, which is 4, 2. So the axis of symmetry would be x equal that x coordinate. The vertex is 4 for the value of x. So that particular line is called axis of symmetry. And then by looking this graph, you can see that the x-intercepts, there are 2 points at 2 and 6. So x, so if there is more than one, separate them with the commas. So 2, 6, and y-intercept means it's the graph is intersecting at -6. So these are the x and y intercept. And then vertex, as I mentioned earlier, the vertex is this point, which is 4, 2. So 4, 2. You just have to put 4 here and then 2 here. Let's try to check the answer. And that's right. Let's go to second problem. Graph the parabola. So you can see here the equation is given. You can compare this equation with the vertex form of parabola, which is y equal a times x minus h squared plus k. If you compare this equation with this one, the vertex for this equation is value of h and k. Just look at the value of h, which is 1. There is a minus sign, so h should be 1. And the value of k is this number with the sign -4. So the vertex is 1, -4. And then after that you need to also use 5 points. So they are saying plot 5 points. We know the vertex is 1, 4. So let's plot that one. 1, -4. Plot that point. Plot 5 points on the parabola. The vertex 2 points to the left. So 2 points to the left of this one. So you can find, you can choose anything. So to the left, we know that the vertex is at 1, -4. So to the left of this one is, you can just choose x equal, let's say 0 or -1. These are the points which is left to this point in the x coordinate. And then 2 and 3, these are the points to the right of this point. The left and right comes from the x coordinate. So the value of y can be calculated by using this equation we have given, which is 3 times x minus 1 square minus 4. Just plug that, and these are the points. That's up to you which point you would like to pick, but you need to pick something from here. To the left 2 points, and to the right 2 points from this point. I just picked 0 and -1. So just pick which one, the points which is easy to to choose, plot, and then when you plug here to calculate as well. If I put x equal to 0 here, then you can see that 3 times x minus 1. I'm going to make it bigger and then show you. So if I put this here, that will be y equal 3 times x is 0 minus 1 square minus 4. And if you do this math, 3 times -1 square is +1. So it's basically 3 minus 4, which is -1. I'm not going to do that again here for -1. I'm just going to plug that for -1. So 3 times -2 square is a 4. 4 times 3 is 12. 12 minus 4 is 8. 2 minus 1 is 1. So 3 minus 4 is again -1. 3 minus 1 is 2. 2 square is 4. 4 times 3 is 12. 12 minus 4 is 8. So these are the points we're going to, plot. 0 for the x coordinate and -1 for the y coordinate. -1 for the x coordinate and 8 is the y coordinate. Similarly, 2 for the x coordinate and -1 for the y coordinate. and finally 3 for the x coordinate and 8 for the y coordinate. The only thing you have to do is finding the value of y at these points. Remember, one more time, you can choose the points of your wish for the x, but always choose the smaller one. That's what I do. And then also you have to look at this frame. If these points are out of frame, then you are not going to, you will not be able to plot them. So the next point, as you can see, it's 0, -1, 0, -1, plot that. Another point is -1, 8, -1, 8. Another point is 2, -1, 2, -1, and finally 3, 3, positive 8, 3, positive 8. Okay, so you can see that it looks like a graph of parabola. So now you just have to select this one, and it will show you the graph, the nature of the graph, and just check it. And that's right. Let's go to the next problem, number 3. One more time. This is a parabola, and for plotting the graph of the parabola, you need the vertex, and you need 2 points to the left and 2 points to the right. We are going to do the very same thing here. And remember, this is not vertex form. Either you can change this equation into vertex form, or you can just use the formula for finding the vertex of this kind of equation. So there is a formula which is if you have y equal a times x squared plus b times x plus c, then the vertex would be -b over 2a, comma, the value of the function, this is y value, at -b over 2a. So if I say this is the function, then find the value of the function at -b over 2a. So if you compare this standard equation with this equation, you can see that a is 3, which is the number just in front of x squared. B is a number in front of x, which is -12, and c is 7. So now the vertex, for finding the vertex, you need to find -b over 2a, -12, because b is -12, 2 times a is 3. So eventually negative times negative is positive, divided by 3 times 2 is 6. So that is 2. You need to find the value of the function when x is 2. So you go back here and just replace that x by 2 and calculate that number. Okay, so if you do this calculation, this is 2 squared times 3 is 12. So that is 12 times 2 is 24. So -12 plus 7 is -5. So the vertex of this parabola is at 2, -5. Now to plot the graph, you need 2 points to the right and 2 points to the left. So I'm going to pick this is somewhere 2, x equal 2. So I need 2 points to the left and 2 points to the right. So I'm going to pick 1 and 0 to the left and 3 and 4 to the right. So that means I need to find the value of the y coordinate, which can be computed by using this formula, the way we did in our problem number 2. We choose x equal to 0, x equal to 1, 2, 3, and 4. These are the 4 points we're choosing. Just put x equal to 0 here, it gives you 7. That means 0, 7 is one of the point. Choose x equal to 1, that will be 3 minus 12, that will be -2. So just do this math here, 1 comma -2. Put 3. If you put 3, then whatever you put on the left side, because you can see that this is the axis of symmetry. Axis of symmetry will pass through this point too. So that means whatever value you get for the 1, you will get the same value for the 3. If you don't understand that thing, just plot x equal to 3 here in this calculation. You are going to get -2. So 3 square is 9 times 3 is 27, minus 36 is negative 9. Negative 9 plus 7 is negative 2. The same point, 3 comma negative 2. If I put 4, then I'm going to choose, because this point will be symmetric to the 0, 7. So I'm going to get 7 here. 4, 7. So just plug x equal to 4 and do the calculation. It will be 4, 7. Okay. 16 times 3 is 48, minus 48 is cancel out, and then leftover would be 7. So these are the points you need to plot, including this vertex 2 comma negative 5. So the vertex is 2 comma negative 5, 2 comma negative 5. Plot. Another point is 1 comma, as you can see that 1 comma negative 2, negative 2. One more time, 3 comma negative 2, and 0 comma 7, and finally 4 comma 7. So after that, if you just use this tool, the graphing tool, it will connect the points. As you can see that, because this graph parabola has this axis of symmetry. The axis of symmetry means it has mirror image. So that means that's the reason this point and this point, the y coordinate would be same. This point and this point, they have the same y coordinate. That's what I was talking. Okay, let's check here. That's problem 3. Go to problem 4. If we need to find out the x-intercept and vertex, it's easier than previous problem. It's exactly problem 3. We found the vertex. I showed you how to find the vertex by using either use the formula negative v over 2a and f at negative v over 2a. That's the formula you can use for finding the vertex for equation like this, or you can convert that into the vertex form. And then another thing is you need to also find the x-intercept, meaning just put y equal to 0 and solve for x. If you do that, the x-intercept would be just solve x squared minus 8x plus 12 equals 0. I'm not supposed to do this because this is exactly same as previous problem, but I'm going to just, let's say, x squared minus 8x plus 12. So x-intercept intercept, meaning the y value is 0, the meaning this is equal to 0. Now if you try to solve for x by using quadratic formula or the factoring, then it will be x minus 6, x minus 2, because 6 times 2 is 12, negative times negative is positive, negative 6x and negative 2x is negative 8x. So these are the x-intercept 2 and 6. And for finding the vertex, you can use the formula the way I used here in problem 3, or you can change it to the vertex form. Because I already used the formula, so I'm going to use the vertex form here. For the vertex form, we need to change this. We need to make this, we need to complete this square here. We need to add and subtract something so that this would be the completed square. For that, we need to add half of it, which is 4 square, and subtract the same thing, and that will give us x minus 4 square for the first 3 terms. And for last 2 terms, you can see that there is a negative 16 plus 2, which is negative, plus 12 is negative 4. Negative 16 plus 12 is negative 4. So if you look at here, you can see the vertex y equal 8 times x minus h square plus k. If we compare with this one, you just have to compare the number after x and make sure that there should be the negative sign. If it's positive, then you have to make it negative. So the vertex, by comparing these two equations, you can find the value of h and k, which is 4 comma negative 4. So the x-intercept 2 comma 6, 2 comma 6, vertex 4 comma negative 4. Let's go back one more time, 4 comma negative 4. Check it. Great. Let's go to next problem. One more time. This is the you need to change this equation into the vertex form and find that vertex. Write it down in the vertex form, and then after that find the vertex, and then after that you have to plot the graph. Exactly the way I did for problem 4, you can convert that into the vertex form and find the vertex. And after finding the vertex, you just need 2 points to the left, 2 points to the right, the way we did in previous problems like problem 3 and then problem 4. They will help you to solve problem 5. So I'm going to skip it. Let's go to problem 6. So as you can see, this is the word problem. So whenever you see the word problem, okay, so whenever we do this kind of word problem, we have to make sure that we need to read it until we understand the problem. A medical equipment industry manufactures X-ray machine. So they make the X-ray machine. The unit cost, C is the cost function in dollar to make each X-ray machine depends on the number of machine made. If X machines are made, then the unit cost is given by the function C of X equals 0.2 x squared minus 100x plus 31,146. What is the minimum unit cost? So whenever you have questions like minimum or maximum thing, you are trying to find the vertex of that quadratic function. Okay, so this is quadratic function. You just need to find the vertex. So for finding the vertex, this is problem 6. So for finding the vertex, you can use this this vertex formula, and that will give you your answer for the minimum cost. So here problem 6, the cost function we have given is 0.2 x squared minus 100x plus 31,146. If I compare this equation with standard quadratic function, I find a equals 0.2, b equal negative 100, and c equal 31,146. Now for finding the vertex, because that point gives us minimum value of this quadratic function, so the vertex can be found by using this formula negative b over 2a comma the value of the cost at that point. So using that formula, negative b over 2a, if you just do the math here, negative 100 divided by 2 times 0.2, which is 100 divided by 0.4. If you do that here, here is the calculator. 100 divided by 0.4, so that is 250, and that is 250. That's the x coordinate of the vertex. I already calculated the value of the function at 250 using the calculator. So this will be 0.2 times 250 square minus 100 times 250 plus 31,146. This calculation gives you 18,646. So the unit cost, the cost uh, uh, this is the value of the cost. This is the cost. So if you plot the graph, you don't have to plot the graph. I'm just trying to explain you. This is the cost function, and the minimum value of the cost function is when x is 250, and then cost for that minimum is 18,646. So if you go back here, what is the minimum unit cost? It's 18,646. 18,646. Okay, that's right. So let's go to next problem 7. Okay, problem 7, the graph of the quadratic function with the vertex is 3, 2, is given here. Find the domain. Domain means what x value you can pick. This arrow means it's keep going to the left and to the right, and we know that domain for the the parabola, the standard parabola, is always all real number. So you can just say negative infinity to positive infinity because there is no restriction. A range always comes from the y value. As you can see that this graph is on the y-axis, this graph is starting at 2 and going up. So the range would be starting at 2 and it will go up and up and up, so you have to put infinity there. So remember, if you are trying to find the range for parabola, you need to use the vertex. Okay, find the range of the quadratic function. One more time, if you are dealing with a standard quadratic function, the domain is all real number, but the range comes from the vertex. There are two situations you have. Let's say this is problem 8. There are two situations. If your parabola is like this, meaning there is a maximum value, so the range means all the real number from negative infinity to this point. But if your parabola looks like this, then this is your minimum value, so the range is all the real numbers starting from here up to positive infinity. In this case, you can see that there is a negative coefficient of x squared, which means the graph would look like this. So after finding the vertex, the range would be from negative infinity to the y coordinate of that vertex. So for finding the vertex, you can use this very same formula, negative b over 2a, and in this case the b is negative 8 and a is negative 2. So you can see that negative 8 times negative is positive 8 divided by negative 4, which is negative 2. So that's the x coordinate. You need to find the y coordinate because the range means it's the y value. So what is the y coordinate? It's the value of the function at that negative 2. So if you just plug x equal to negative 2 here, it will be negative 2 squared, negative 8 times negative 2, negative 9. If you do this calculation, which is negative 2 squared is 4, 4 times negative 2 is negative 8, positive 16. So that is positive 8 minus 9 is negative 1. So the vertex is at negative 2, negative 1. So the range would be negative infinity up to negative 1. So the range would be starting from negative infinity up to negative 1. Okay. Problem 9. I don't know why it's taking time. Okay, it's taking time, so okay, so let's go to problem 9. Graph the solution to the following inequality on the number line. So we have given inequality. To graph the solution, always we have to start with the 0 of this inequality. So problem 9. So here is the inequality we need to solve. To solve this kind of inequality, always start with making this side 0 and solve for x. Okay, if you don't have everything on one side, make everything on one side and equate that side to 0 and solve for x. And now after that, let's assume that this everything is, let's say this is f of x. Okay, that's the function you want to find out where this function is greater than or equal to 0. So just plot this two zeros of this function, which is negative 2 and negative 3 on the number line. So now look at the number line and now divide this negative 2 and negative 3, which are zeros of this function, divide this number line into 3 intervals. So starting from negative infinity up to negative 2, negative 2 to negative 3, negative 3 to positive infinity. Now we need to check where this function, on which interval this function is positive and 0 or 0. So we already know that this function is 0 at -2 and -3. So these are the answer. -2 and -3 will be will be in the answer, but we also have to find out where this function is positive as well. So for that we need to pick some testing point from this intervals we found. So for the testing point, you can choose any point as you like from these intervals. So I'm going to choose from here, let's say -3. It's easy to choose. Here it's let's say -2.5, because it's in between -2 and -3. And then okay, I just have to switch it. Okay, it should be -3 should be here and -2 should be here. That's the mistake, because negative number. So it should be from -infinity to -3, -3 to -2, and then -2 to positive infinity. Okay, my bad. So oh, I missed something here. It's a negative x minus 3, so that should be positive 3. Again, my bad. So let me just correct that information here. I'm going to erase that. So it should be -2 and positive 3. So -2 and positive 3. Okay, -2 and positive 3. Positive 3. Okay, so that should be -2 and positive 3. So it would be -infinity to -2, -2 to positive 3. It's positive 3, and from positive 3 to infinity. So we are going to choose some testing point here. So as I mentioned, from here I would choose -3. From here, because 0 is here, I always pick 0 because it's easy to check. And from here I'm going to choose 4. And now we need to find out the value of the function at these testing points. The function is x plus 2 times x minus 3. So if I pick the value of the function at -3, because the function is x plus 2 times x minus 3, so just plug x equal to -3 there. It will give you -3 positive 2 times -3 -3. So this will be the negative number, this will be the negative number, eventually it will be the positive number. We just care about positivity or negativity of the function, but you can also find out the value. That's up to you. It's -1 times -6 is positive 6. So that's the positive. So the meaning is the function f of x, this expression will be positive on this interval. So here is the positive. And we're going to do the same thing. We're going to check at 0, and if you put 0 here in the function, it will be 2 times -3, which is -6. So negative here. Finally, if you put 4, f of 4, and that will be 4 plus 2 is 6, 4 minus 3 is 1, so it will be positive 6. So here is the positive. So the answer for this inequality, where we are looking for where this function is positive, so this is the interval where the function is positive. This is the interval where the function is positive, and the function is 0 at -2 and positive 3. So that means the solution would be from -infinity to -2, including -2, union from 3 to positive infinity. But before using this union sign, let's read the instruction we have given here in the problem. Oh, we don't have to write it down, we just have to plot them. So it's from -infinity to -2. So we need -2 here, and we need positive 3, and then after that we have to choose this one. This is the reason we need, this is the reason we need. So you can see that my answer is this part and this part, including -2 and positive 3. Okay, let's check it. Great. Let's go to next problem, problem 10. This is very similar problem, but here you need to change this 8 to the left side first. So problem 10, we need to solve x squared plus 2x is greater than 8. So we can just bring everything on the left side and make the right side 0. You always have to do that. And now let's say this is your function f of x, and now we need to find where this function is 0. So that means you need to solve this quadratic equation. If you try to solve this, so that means that would be so what is that? A positive 4, negative 2, positive 4 and negative 2. You can use the factoring method, or the formula, or the square root property. That's up to you. It gives me negative 4 and positive 2 are the two zeros. So I'm going to repeat the very same thing like we did in problem 9. We have to just split this real number line by using these two zeros. Negative 4 is here, positive 2 is here. So we have 3 interval where we need testing points, and we need to test this function where this function is positive only, not 0. This time we're not including 0. So if you just try to pick testing points from here, these 3 intervals, let me use different color here. So let's pick the testing point from here. The easy one, I would say negative 5. It's 0 because 0 is there. If 0 is there, I would always choose 0. And if I find the value of the function at negative 5, I put negative 5 here in the function. That would be negative, negative, positive. So that will be positive. Trust me, just plug that value x equal to negative 5 in the given function. The function is this part. 5, negative 5 squared is 25, negative 10, negative 8 is positive number. All we care is either that function is positive or negative. If I put 0, as you can see that if I put the 0 in the function, it would be negative 8. That's why it's a negative. If I put 3, as you can see that it's 3 plus 4 is 7 and 3 minus 2 is 1, so that is again positive. So the answer is, you can see the answer is this one, it's positive, this one is positive, and here it's negative. So the answer is this function would be positive on the first interval and then last interval. Let's see how they're asking us to put the answer. So this time, because zeros are not included, you have to use the circle at these zeros, negative 4 here and positive 2. Positive 2. Okay, negative 4 and 2 are the zeros. We are not including them, and we need graph left interval and then right interval. So let's check that. Correct. Let's go to next problem. By looking these graphs, we need to find out which one is one-to-one. So for the one-to-one, you just try to find out, you just try to use the horizontal line test. If any horizontal line, any horizontal line, any crosses that graph at more than 1 point, then that's not the one-to-one. So here you can see that I can clearly see that even the x-axis, which is a horizontal line, is crossing 2 points, so it's no. Here, each of the horizontal line, on each of the horizontal line, here at negative 4, there are 2 points, so that means it's no. Same thing, 1 point, 1 point, 1 point, 1 point, 1 point, 1 point, so it's yes. Here, if you draw one line, it will crosses one horizontal line, it will cross 2 points through this graph, so it's no. This is 1-1 because no horizontal line will intersect more than 1 point. This is not, because if you draw any line above here, it will cross more than 1 point. So this is horizontal line test. Let's go to next problem. Problem 12. We have given function f of x and g of x, and we want to find out the composition of these functions. So for the first part, you can see that f of x is 6 over x and g of x is 6 over x as well. find the composition, and we need to find out either these functions are inverse of each other or not. And there is a definition. It says if the composition from both direction, both order, gives you x, then they are inverse. So let's try to find out that. This is problem 12. Problem 12, the first part, A, the composition of f g of x is, just plug g of x in the function f of x, 6 over g of x, which is 6 over, plug the value of g of x, which is again 6 over x. Finally, if you flip it, 6 and 6 cancel out, it will give you x. So here you have x. So you also have to find out the g composite f of x. And because both of them are the same function, the output would be again x. So that means here is x, here is x. So these functions are inverse of each other because the composition from both direction gives you, they give you x. If you try to do the same thing here, f composite of g of x, try to plug g of x in f of x, which is negative x plus 8. So that means negative x plus 8 plus 8. I'm just plugging g of x here, and now I'm plugging f of x in g of x. So that will be negative x, negative 4, and positive 4 cancel out, so it will be eventually negative x. As you can see that, the composition from no direction is giving you x and x, so that means they are not inverse of each other. Let's check. Great, let's go to next problem. Problem 13, and you can see that the inverse means reverse. So g of x is given, and inverse of g of x, as you can see that you need to find out negative 3 on the y coordinate. Negative 3 is here, so if you go back, the g inverse of negative 3 should be 9. It's opposite. This is the y coordinate, you need to find out the x coordinate. H inverse of x, so for that you have to use the the step-by-step process for finding the h inverse of x. This is problem 13. Problem 13. For the problem 13 here, you can see that there is for the g of x, one more time, for the g of x, so 9 goes to negative 3, so inverse means g inverse of negative 3 is 9. That's why I put 9 there. For h inverse of x, there are some steps you need to follow for finding the inverse. And first of all, you need to write it down as a y and x. That's the first step. And second step is you need to just interchange x and y in this equation, so that will give you x equal 3 times y plus 8. After that, you need to solve for y. So solve for y. If you try to solve for y, I'm just going to subtract 8. So it would be x minus 8 equal 3y, because I need y only, so I have to divide both sides by 3. So y equal x minus 8 over 3. And eventually this y can be replaced by the inverse of the function, which is x minus 8 over 3. So this is x minus 8 over 3. So x minus 8 over 3. X minus 8 over 3. The answer for this is composition of inverse of two functions always gives you whatever input you take. So finally the answer will be the same thing, negative 4. So that's right. So let's go to next problem. F inverse of x, do exactly the same thing I did here for previous problem. Just write it down the function as a y and x, switch x and y, solve for y, and finally you get the answer. So problem 14, that's the inverse function problem. And the one extra thing is the domain of this inverse function is the range of this function. Okay, so the domain of this inverse function is the range of this f of x. So what is the range of this f of x? The domain is 4 comma infinity, so what is the range? you can find the f inverse of x, and from there you can find the domain. So let me just do this thing here. I need some extra page. So so this is problem 14. Problem 14, as you can see, f of x equal square root of 3x minus 12. So if you try to plot the graph of this function, this is the square root function, and then you can see that when x is 4, so y is 0. So this is the graph you're going to get for square root of 3x minus 12. So you can see that the domain is from 4 to infinity, and range is starting from 0 to infinity. The range of this function is 0 to infinity. So for this function, the domain is from 4 to infinity and range is from 0 to infinity. After finding the f inverse, the domain of f inverse would be 0 to infinity because it's just a switch. But how do you find the f inverse? First of all, write down that function as a y and x. After that, just switch x and y. So I'm going to replace this y by x and this x by y. Now we need to solve for y. To solve for x, we are just going to square both sides, and then finally we're going to add 12 both sides because we're trying to solve for y. So x squared plus 12 equals 3y. So what is the value of y? The value of y is x squared plus 12 divided by 3, and that is f inverse. F inverse of x equals x squared plus 12 divided by 3. Okay, so that is our x squared plus 12. If you just look at this one, you can see that the domain of this function is all real number, but that is not true because the domain of this function is actually coming from the range of this function f itself. So the domain of that function would be 0 to infinity. So let's just write it down here, and you can always check either this is inverse, this is right or wrong by finding the composition of these two functions. F composite of f inverse of x from both directions should be same. If you are confused, like either this is the right answer or not, you can always find the composition and you can make sure that it should be x. So f inverse of x is x squared plus 12 divided by x squared plus 12 x squared plus 12 divided by 3, and then domain is all real number from starting from 0 to positive infinity. That's right. So don't be confused by just looking the f inverse of x. It takes any real number, positive or negative, but the domain of this function to be inverse of this function, it should be all positive real number only, and that comes from by looking the range of this function. Okay, that's a tricky part. Okay, let's go to next problem. Problem 15. One more time. So this is inverse problem. You can do exactly the same thing the way we did in previous problem for finding the inverse. Just write it down in terms of x and y. Just replace that f of x by y. Switch x and y and solve for y. That will be the inverse. I'm not going to do it the same problem. So let's go to problem 16. Again, it's a inverse function and then domain of h inverse and range of h inverse. Always use the domain of h of x for finding the range of h inverse. So I'm not going to do it again, do it also, but I'm just trying to give you the idea. This is h of x, which is x over 6x minus 5, and after you find the h inverse by using the same trick the way we did here before. For finding the domain and range, the domain of H is actually the range of H inverse. Okay, so the domain of H is the range of H inverse. So you don't need to find out range of H inverse, and range of H is the domain of H inverse. So if you can find the domain and range of H of X, that will help you to find the domain and range of H inverse. It will be just it's just the opposite. Okay, so I will just let you do this thing. It's very similar to the previous problem. You just have to know the relation between the domain and range of H and H inverse. Let's go to the next problem. So the function f is given. You need to plot the graph of f inverse. One more time, these are the two lines. You just need to plot the graph of f inverse. Remember, the graph of f inverse can be found by just switching the x and y coordinate. Look at here. To plot the graph of f inverse of this graph, you just need to use these boundary points. This point, the end point, this point, and this point. You just need to plot 3 points by switching their x and y coordinate. The first point, you can see that the x coordinate is 7, the y coordinate is 4. So just switch it. Make x coordinate 4 and y coordinate 7. I'm just switching the x and y coordinate. 7 4 becomes 4 7. But you have to choose the right point, the end point. So another end point is this one, which is positive 5, negative 2. That becomes negative 2 and negative 2, negative 2, and positive 5. I'm just switching x and y coordinate. Okay, and this is the inverse of this point. And finally, if you go to this last point here, the coordinate of this last point is negative 5, negative 3. If you switch the x and y coordinate, it would be negative 3, negative 5. And if you just plot them, and now you just have to join these 3 points using the lines the way you have they have joined these points. You have to do the same thing. Start from here, go up to that point, pick another one, start from that point, and go up to this point. And this is the inverse function of each other. And remember, the inverse function, the graph of inverse function, if you draw a line through this origin, that line should divide, that line should behaves like, if you place the mirror on that line, they should behave like a mirror image. The idea is, for plotting the inverse function, you just have to switch the x and y coordinate of the given function. Let's check. Great. Let's go to the next problem. Problem 18. We have given we need to plot the graph of exponential function. So first of all, you need to know what is the graph of 2 to the power x, and then this is just shifting 2 units up. Okay, and remember, the graph of 2 to the power x is, this is the exponential function. The graph of 2 to the power x, it looks like this one, 0 1, always goes from 0 1. You're just shifting this graph 2 units up. So you have to choose the right notation, and then we have horizontal line for that one, and after that you have to shift that horizontal line 2 units up. So let me start. That horizontal line will go up 2 units, and then the graph will pass through at 0. It will be 3. 3 is here. So you just, if you want to find out another point would be just plug x equal to 1, and that would be 2 to the power 1 is 2, 2 plus 2 is 4. So these are the 2 points. Look at here. Initially, for the graph of 2 to the power x, this is the graph of 2 to the power x. This is the 1 point, and I can choose another point 1, 2. These are the 2 points. And now our horizontal asymptote for this graph is y equal to 0 line. Now we are shifting this, you want to plot the graph of 2 to the power x plus 2. The meaning is you are shifting everything of this graph 2 unit up. So this horizontal asymptote will go up by 2 units. So that's why you can see the line through 2. And then these points, again, if you look at this point, 0, 1 becomes, 0, 3. 1, 2 becomes 1, 4. You can see that 0, 3 and 1, 4. Okay. And now you can see that the domain is, as we know, domain for the exponential function is all real number. So it's all real number. We don't have any problem with that. And then range comes from this horizontal asymptote. Range would be anything up than this horizontal asymptote. You are not including this horizontal asymptote. So that means, open parenthesis, starting from 2, you go up to infinity. As you can see that the graph is going up and up and up, but graph is not crossing this horizontal line, horizontal asymptote y equal to 2. That's why it's a 2 comma infinity, not including 2. Let's check the answer. Great. Okay, problem 19. Oh, the graph is given. You want to just use the same graph and you want to use the transformation. As you can see that e to the power x is this, e to the power negative x, it's a reflection because x becomes negative x. So whenever you change x to the negative x, it's a reflection about the y-axis. So you need to use this one. Okay, reflection about across the y-axis is this one. Make sense? And then this is shifting 5 unit down because you are subtracting 5. So you take this function and you take it 5 unit down. So this 0, 1 becomes 0, 4, negative 4. Negative 4. Where is that? Yes. You see that? I took that 0, 1 point to the 0, negative 4 because I'm subtracting 5 from the y coordinate. So I use reflection across the y-axis because x is changing to the negative x. And then a negative 5 means we are subtracting the y coordinate. We are subtracting 5 from the y coordinate. That means it's a vertical shift down. Now, by looking this graph, you can find the range. Range always start from this horizontal line, which is at this point it's negative 5, not including negative 5. So negative 5 goes up to positive infinity. And domain is, one more time, this function is defined for any real number. So the domain is from negative infinity to positive infinity. Right. Okay, this is the same idea. You are taking e to the power x, shifting 2 unit to the left, and then vertically stretching, and then subtracting 2. That means vertical shift down. You need to find out the points, plot 2 points on the graph of the function, and you also have to draw the asymptotes. So this is an exponential function e to the power x. So you can find out the 2 points on this. Let's just let me just do this one. Problem 20. So remember, for problem 20, you have to understand the transformation. This e to the power x is going to e to the power x plus 2, and you are multiplying this by 2, and then finally you are doing the vertical shift. So if xy is a point on this graph, this horizontal shift means it's x minus 2y. As you can see that you are adding 2 to the x coordinate, that means you are subtracting actually. This means you are multiplying the y coordinate of the previous stage by 2. So that means the point will now x minus 2 times y. Finally, you are subtracting 2 from the previous stage. So that means you are subtracting 2 from this state. So finally x minus 2 comma 2 times y minus 2. So any point xy from this original exponential function becomes x minus 2 comma 2y minus 2. As you know, the horizontal asymptote of e to the power x is y equal to 0 line. because you are shifting this graph 2 unit down, then horizontal asymptote would be y equal -2. Okay, and for finding the any 2 points here, you can take any 2 points from here and then just use that formula. So on e to the power x, this is our graph, e to the power x. So the first point is, let's say, 0 1. Second point you might choose I don't know, 1e. If you put x equal to 1, then value of y is e. You can use calculator for finding this value. And then this is your horizontal asymptote. This is your horizontal asymptote, which is y equal to 0. Because you are shifting this graph 2 unit down, so this horizontal asymptote will come here, which is y equal -2. And these 2 points changes using these formulas. This 0 1 becomes 0 -2, which is -2. -2 is here, 1 2, and 2 times y minus 2 becomes 2 times 1 minus 2, which is 0. So this point becomes this one. And for shifting this 1 comma e, just put x equal to 1, which gives you -1. So this is -2 0, and just put x equal to 1 here. That will give you -1, because 1 minus 2 is -1. And for finding the y, 2 times e minus 2, just use 2 times e minus 2, so somewhere here. So at -1, it will be 2 times e minus 2. I'm going to use these 2 points here. Look at here how I'm going to do it. You don't need to find exact value of e. You can use the interim of e as well. So the horizontal line would be x equal to -2, and 2 points. The first point is at -1, the value is 0. So plot it. And another point, I'm sorry, at -2 the value is so this is not right point. Okay. So let me just start again. -2. The first point is at -2 the value is 0. So at -2 the value is 0. Or that one. And at -1 the value, as you can see, that at -1 the value is 2 times e minus 2. So we're just going to write down 2 times e minus 2. So e is already given here, so you don't have to. So you can see that point is here already. So 2 points are enough. Plot 2 points on the graph of the function and use this curve that will plot the graph. Okay, correct. Let's go to next problem. For finding the value of this thing, it's very easy. Just use this calculator. 260. So 260 times e to the power 0.25, and that is 333.844. And if you want to round, do not round any intermediate. Round your answer to the nearest thousand. So that would be 333.847, nearest thousand. So that means instead of 6, because the next number is greater than 5, it should be 7. You can do the same thing for next one, e to the power negative 0.3. So that is 0.741. Don't forget that you are rounding to the nearest thousand. So this third number, you have to round it. Check your answer.